All right, let's go through Chapter 7 test. It says, determine the following probabilities and state whether the probability is theoretical, relative frequency, or experimental, or subjective. And you're supposed to explain your choice. Drawing 2 aces from a deck of cards. Well, there are 4 aces in a deck out of the 52. And so that's a chance of drawing the first ace. And then it says without replacement. So if you get an ace, then the probability of getting the next ace, well, there's only 3 to choose from out of the 51. And 4 into 52 is 13, and 3 into 51 is 17. This makes 1 over 221. So I've determined the probability, and what kind of probability was this? Well, we didn't collect data from an experiment, so it's not experimental, it's not the relative frequency, and we didn't make it up, we calculated it from what every card being theoretically equally likely, so this is theoretical. Because based on what the options are to get the 2 aces, okay? You earning a 90% on this test. This is your first time taking the test, so there's no history of your taking the test here. You might have some sort of feeling about it, and that would make it subjective. But I also said determine the probability. Now, if you've got some sort of feeling that says you're going to get a 90%, around 90%, you think that's going to happen. It probably happened. You might put down 80% chance, or 0.8 probability, or 0.9 probability. If you think it's highly unlikely you would, you might put down 0.3 or 0.4. But since it's subjective, you make it up. Now, I think I would probably do pretty well on this test. I think I've got a pretty good chance to do at least 90%, so I'm going to put it at 0.9 for me, but you would have to pick one for yourself. And since there's no data to go by, we don't know the likelihood of anything here, so we can't calculate a theoretical or the experimental, and so it's subjective. Okay. 2. Bhaskar has got a wardrobe in for his day on campus. Of course, he wants to impress the gals. He has 1 pair of shorts, and he wears those every day. Not too impressive. And 3 different shirts. So his first choice, he doesn't have to choose shorts, so I don't have to put that on here. Now, a lot of you said, okay, shorts and then. His first choice, that's when we make a dot, and then we move from there, is one of the shirts. And he could choose the Mariner shirt, the Sounders shirt. Oh, and there's a Hawks shirt in there. So you might have the Hawks shirt on top, the Mariner shirt, and the Sounders shirt. He needs to also decide what to wear, whether to wear only his baseball cap, his gold necklace, or his sunglasses, or he may wear none, or some, or all. So therefore, this is like the condiments at the sandwich shop. You can choose to have the ball cap's the first thing I think. You can wear the cap, or not wear the cap. Wear the cap with this Hawk shirt, or not wear it. Wear cap with the sounder shirt or not wear it. And then he can decide whether to wear the necklace or not the necklace. Necklace, not 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 necklace. And then he can wear the sunglasses or not. 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 I'm getting these kind of pushed down here. Sunglasses or not. Sunglasses or not. Sunglasses or not. Finally, sunglasses or not. That's what your tree diagram should look like. And how many outfits does he have to choose from? We can count down the line here how many branches end out here, but you could also say there was 3 choices for the first. Then you had 2 choices on whether with the ball cap, wear it or don't. 2 choices with the necklace, wear it or don't. And 2 choices on the sunglasses, wear them or not. 6 times 4 is 24 outcomes. What's the probability that he wears a cap and a necklace? The cap, this cap has necklace twice. Now you just can't say cap and necklace, that's 1, because it goes, you got to go clear to the end of the branches. So there's 2 branches there that have cap and necklace. There's 2 branches here and 2 branches there. So that's 6 out of 24, all 24, which is 6 goes in there 1 and 6 goes in there 4. Okay? You could also get it from multiplying 1/2 chance of choosing the cap and times 1/2 chance of choosing the necklace. What is the probability that he wears a hawk shirt or has sunglasses on? Well, the hawk shirt is 1/3, or you could say the hawk shirt has 8 out of the 24, that's 1/3. This is or, so we go plus. He wears sunglasses. Half of these have sunglasses. Minus anything we've counted twice, and that would have been hawk shirts and sunglasses. Hawk shirt has 8 outcomes, of which half of them are 4 of them are that, so we'd have to take 4 out of the 24. Or you could say 1/3 times 1/2, which is 1/12. 1/3 times 1/2, 1/6, or 4 out of 24 if you made it common denominator. So 1/3 plus 1/2 is, if we make this in 6, that's 2/6 plus 3/6 minus 1/6 is 4/6, or 2/3, which is the same as, if we go to 24, 16 out of 24, and we could go up here and count. Hawk shirt, 8 of them, or sunglasses. Of these 8, there'd be 4 that have sunglasses. Of these 8, there'd be 4 that have sunglasses. So we would get 8 is 16 out of the 24. And finally, the probability that the shirt is Mariners or Sounders. Mariners or Sounders is 2/3 of them, or 16 out of 24. Or he doesn't have a necklace. Well, half of these don't have a necklace. So and it's or, so you would add 1/2, which is 12 out of 24. But then we'd have to subtract anywhere where they have a Mariners or Sounders and a necklace, because we've already counted them. Mariners with a necklace is 2, 4, half of them. And Sounders is half of them, 4. So that's 4 and 4 is 8 out of 24 that we've already counted that we got to take away. So 16 minus 8 is 8 plus 12 is 20 out of 24, which reduces to 4 goes in there 5 and 4 goes in there 6. 5, 6. Okay, that's page 1. Page 2. Imagine that a game you draw a random ball from a bag containing 10 white, 10 blue, and 10 red without replacing the ball after you draw it. Then do it again and again without replacing 4 total balls. What is the probability of getting at least one non-white? So non-whites are, what's the probability of getting at least one red or blue? That's what a non-white is, right? Okay. So the probability of getting at least one is 1 minus probability of getting no reds or blues. Okay. Now we got to do 4 of them. So what's the probability of not getting a red or blue? Well, that would be getting a white. And there's 10 out of 30. And if I don't replace it, then there would be 9 to choose from out of 29 times 8 out of 28 times 7 out of 27. That's the probability of getting no reds or blues, which just means getting all whites. And 1 minus that is going to be at least one that's not white. And if you do work that out, you'll get the correct answer on that. Okay? Suppose you're tossing 2 fair dice. Event A is tossing at least 1 dice shows a 2. And it says show the sample space. And so I recommend that if you're going to do this with dice, there's 36 outcomes. Instead of listing all the possible pairs, it's easier just to draw a diagram for all of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Event A as at least one of the dice is a 2. That's an A, 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 and that's an A, that's an A, that's an A, that's an A, and that's A. 11 of them. And B is sum of 7. So we can see that there are 2 places that have sum of 7 and at least a 2. A 5, 2 and a 2, 5. So now we can answer the questions. It says fill in the table. A, there was 11 A's, so that probability of A is 11 out of 36. B, there was 6 B's, so B is 6 out of 36. A and B, that would be the overlap, which is the 2 out of 36. So if there's 6 total B's and 2 of them are in A, then the other 4 must not be in A. There's 11 A's and 2 of them are in B, and so the other 9 must not be in B. And we have 36 total out of 36, or 1. And if we got 6 out of 36 there must be 30 here. And if we got 11 here, 11 from 36 is 25 here. Which means 9 plus 21 is 30. And 4 plus 21 is 25. Looks like the table is working. Determine the probability of not A. Not B. Not B is 30 out of 36. Which reduces to, see, 6 goes into those 6 times. D, A or B. Well, A is 11/36, B is 6 out of 36, so it looks like it'd be 17, but we just counted those two twice. So it's really 17 minus 2, 15. Or we can just add these up. 9 plus 2 plus 4 is 15 out of 36. 3 goes into both of those, and that would be 5/12 if you wanted to reduce it. Probability of A and B, 2 out of 36. A, if we're given B. So if we're given B, we go to here and say, okay, B has 6 in there. How many of those are A? 2 of those 6. B is what we put in the denominator, how many there is. You can write 2 over 36 over 6 over 36, but the 36 is canceled. So it's 2 over 6, or 1/3. That's the probability of A happening if you know B has already happened. And to check independence, you would compare that to just the probability of A. Well, we said the probability of A is 11 out of 36. Now, did the probability of A change knowing B happened? It went from 11/36 to 1/3. 12/36 would be 1/3, but this is 11/36, so these are not the same. So, dependent. Okay. Page 3. How many distinguishable permutations of the letters of balalaika? Okay, well there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in balalaika. So you could arrange them 9 factorial ways, but they wouldn't all be distinguishable. You could swap around some A's or some L's or whatever else there's duplicated, and so we got to cross out those duplications. There's 1, 2, 3, 4 A's in this, so we'd have to divide by 4 factorial. And there's 2 L's, so we'd have to divide by 2 factorial. There's only 1 B, 1 I, and 1 K, and so this would be our answer. So that would be 9, 8, 7, 6, 5, 4, 3, 2, 1. over 4, 3, 2, 1, and 2, 1. And 2 would go into 6, maybe 3, and so if we multiply those, you'll get the answer. 6. How many ways are there to pick 3 different candy bars from a display that has 35? Well, there's 35 choices for the first one, times 34 times 33. But we don't care what order, so we have to get rid of the order. We don't care what order we get those. And so this implies a candy bar first, then a different one second, and a different one third. We got to get rid of that, so we divide by 3 factorial. And this is the same as don't care about the order, the combinations. We want to do 35 NCR, choose 3. We use the C when we don't care about order. Now, 7. The coach has to pick 6 starting players and assign them to position if there's 11 players. So they're going to have 11 times 9, 8 and 10, 11 times 10 times 9 times 8 times 7 times 6. There's 1, 2, 3, 4, 5, 6 players. 11, 10, 9, 8, 6, 7, 8, 9, 10, 11. Yes. This implies an order. Do we want order? Well, if they're going to assign them to positions, then there's specific order to them out on the court. So that would be our answer, which is 11 players pick and arranged into 6 spots. And you can work that one out on your calculator. Okay, suppose a gambler is offering folks. So the gambler is going to offer to play the game. So there's a gambler and there's players. And the player gets to roll 2 dice. If the player rolls a matching pair, so if we just made our little grid here, the matching pairs are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. The player wins $1 for every dot showing. Well, a 2, 2 would be a $4 win for the player. A 3, 3 would be a $6 win. A 4, 4 would be an $8 win. $10 win. And a $12 win. Now on a 1-1 or snake eyes, the player loses $5. Plus the player has to pay $1 to play, it says here. So, if 500 plays are made today, how much money will the gambler, this is the one who's offering to the player to play it, expect to pay out? He doesn't pay out the $1 for each play. He only pays out when they win. When they roll snake eyes, he doesn't pay out the $5. He pays out the $4. That's the value. Times the probability, that happens 1 out of 36 times. Plus he pays out $6 times 1 out of 36 times, and he pays $8 1 out of 36 times. Those are multiplied, plus $10 1 out of 36 times, plus $12 1 out of 36 times. And you are expected to multiply this out. So 436 plus 636 plus 8 plus 10 plus 12. 12 and 8 is 20, plus 10 is 30, and 6 and 4 is 10, so that's 40 out of 36. See, 40 goes into, 10 goes, no, 4 goes in both of those. That would be 10 out of 9, which is 1.1111, I think. Okay? So, the gambler expects to pay out $1.11 on every play, and if he plays 5,000 times, it'd be that times 5,000, which is just 1, 2, 3 places and times 5, so that'd be $5,555.55, I believe, that he pays out. It would be 5,000 times 10 ninths, whatever that works out to be. I think 5,555. Okay. C. What's the expected value per game for the gambler? Well, he's expected to pay out 9 of 40, 36 per play, but he is also going to get in, so that's a negative amount because he's paying that out. He's going to bring in $5 1/36 of the time, plus $1 per every time they play, which is $1 times 36 out of 36 times. So that makes it minus 40/36 plus 5/36 plus 36/36. So this is 41/36 minus 40. That's 1/36 of a dollar he expects to win every play. That's about 2 cents, $0.027 or something like that, I believe it worked out to be. So how much would the gambler make over 500 plays? So then you would multiply how much he makes, which is 1/36 of a dollar per play, times the number of plays. And so you're going to get 5,000 divided by 36, which is the answer to that problem, whatever that works out to be. Okay. If there are 27 billionaires and 10 million people, then how many billions would there be? How many billionaires would there be in 315 million people? So it's a ratio problem. And to solve for x, you would multiply both sides by 315 million. And these 7 zeros would cancel 7 and make it 31. 27 times 31.5 is the number of billionaires. So if you can multiply those, you'll get the answer. And finally, 10. These should have been bullets, not A, B, and C, and there's only one question here. And the question is, how many new cars are involved in accidents per 100,000 miles driven in the first year of ownership? So 6,750 cars are involved, new cars are involved in accidents. That's how many accidents out of And it says miles driven. So each car has driven 14,000 miles, and there's 2.3 million cars. And this is miles per car. So the car units cancel, and so this becomes the miles in the denominator. But you're supposed to do this out of 100,000, so we multiply by 100,000. And we get our answer. Now that 100,000 would cancel the 5 zeros on that, and so we'd have 6,750 divided by 14000 times 2, 3 times 23. And you can work that out. It's not very many. Okay? That's that test.